Thank you so much, everyone, for joining us. To all those who have just joined us, welcome, a very warm welcome to all of you, in fact. We are thrilled to have you here for today's session, which is
Recording in
using
progress.
NLP and NER to unlock hidden insights from unstructured data. I'm Soini, I'm a user success manager at Hyperflex. Hyperflex is an Elastic certified partner founded by former elasticians and Elastic engineers. Our team includes 20 plus Elastic certified engineers, and we work across sectors to help companies get the most out of their Elastic stack. We offer consulting, implementation, managed services, and migration services. In today's session, we will give you practical insights into how NLP and NER can turn messy data into valuable insights. Joining us today are our speakers, Mihalis, Senior Data Engineer at Agrono, George, Data Engineer at Agrono, and Bhavesh, Elastic Engineer and our in-house expert at Hyperflex. I'll hand it over to our speakers to introduce themselves. But before we begin, please feel free to drop your questions in the chat box anytime. We will take it up in the end. We have a dedicated Q&A session. That's when we'll answer all your questions. So, yes, to kick things off, I'll turn to my speakers and I'd let them introduce themselves and maybe tell us one wow moment that they had with Elasticsearch recently. So, Bhavesh, shall we start with you?
Sure. Thank you, Sohini, for the warm welcome and welcome everyone for this webinar. I am co-founder and CTO of Hyperflex, specialized in observability domain. I have been working in this industry for more than 6 years now and have worked on good use cases of Elastic. Today, very excited to take this webinar forward for NLP and NER and how we use it for structuring the unstructured data. Uh, if I talk about any wow movement, then probably that I saw recently Elastic launch a couple of new features in the ninth version using AI and all. Seeing our Elastic going in the same way is what made me amazed. So I would say that's one wow moment for me that they are also working in this industry. Over to you, Mahalis.
Amazing. Thank you both, Bhavesh and Sohin, for the welcome and the introductory words, and hello to everyone from me as well. I am Michalis. Before we start, super thanks to the Hyperflex team for having us in this webinar, and of course, thanks to everyone in the audience for joining. As I said, I am Michalis. My background is in computer science. I've been working as a software slash data backend engineer for roughly 15 years now, most of them focused on the data engineering aspects, and I'm here representing Agrono, in which I'm employed as a data engineer and also leading our data team. A member of our team is also George, who is here with us today. George, care to say a couple of words?
Thank you, Michalis. And thank you the Hyperflex team for the invitation. We're very pleased to share with you how we utilize Elasticsearch to solve our day-to-day problems. I have a 3-year experience in the industry. I work with Michalis in the same team in Agrono, and I also have a computer science background.
Amazing. Thank you so much. And the floor is all yours. So, Bhavesh, would you start?
Sure. So, welcome again, everyone. I am really excited to kick off today's session. And before we deep dive into any specific use case like food recall industry that my co-speaker will be covering today, I would like to set a stage by exploring the bigger picture. And you guys know that we live in a world flooded with unstructured data, where we have product reviews, patient notes, supported logs, and legal document. But these text documents don't have insights which you can easily take an access from or analyze easily. So now think about the information that's bird in a call center transcripts or clinical notes or contracts, and it has incredible values in it, but they are often overlooked because it's messy and it's unstructured and it's very hard to process it. So the question arises, how do we unlock it? And what we could do to extract the structure out of these chaos for searching, visualizing, or acting on it instantly. So that's where NLP, NER, and Elastic help us to work on it. And today's I'll show you how we can do that. So for today's session, we will be covering this agenda where first we'll be discussing what's in detail NLP NER is, its capabilities with Elasticsearch, the challenges of having an unstructured data, and the solution that we have using NER and vector search. After that, we'll see some implementation, cross-industry use cases where we can utilize NER in real-time industries, and the benefit and business impact of utilizing this in our use cases. And some final thoughts for me from my side, and then we'll probably move on to the next stage in where we'll be presenting a demo of food recall industry. So with that being said, I'll talk about what is NLP and NER. So NLP stands for natural language processing, and it teaches machines to understand human language. And a subfield of NLP called NER, which is named entity recognition, it's a key term where it identifies key terms from our text like people, organization, drug names, dates, or symptoms from the message that we have. So let's say, for an example, I have a text message like Amazon acquired Whole Foods for $13.4 billion. In here, my NER text will be generated as ORG, my organization is Amazon, another organization is Whole Foods, and my money tag is 13.4 billion. So once these tags are there to help you search, filter, analyze your data in near real time. And the Elastic does not stop at NLP or NER. It supports wide range of NLP operations that can be used during the time of document enrichment or real-time searching for our data. What is when we talk about what exactly these operations are? So Elastic uses transformer-based machine learning models where we have BERT to apply some powerful NLP task to the unstructured data, such as tagging, classifying, and embedding text. All these are helpful for indexing and searching purpose. I'll drill down onto the specific ones where we'll talk about extracting information, language identification, and search and uh, compare text for using our different models. As we know, NER extract the real world entities from the text we have and give you the insights like organization name, location, symptoms. So it usually help making unstructured text easily searchable and filterable for the users. For example, I have a input text. Elastic is headquartered in Mount View, California. From this input, my model will figure out that Elastic is an organization and it will tag it as an organization. Mount View is a location. California is a location. So it will have two different uh, tags like location for Mount View and California. Then we have a fill mask. So it will help predict missing word from a sentence based on the surrounding context. So let's say if I have an input, the capital city of France is Mask, then my model will generate the answer Paris because Paris is a capital of France. And that's how fill mask model works. When we talk about question answering, then it will ask a question. We can ask a question to the model, and it will find the answer directly looking at the block of input context we have provided it to. So it's ideal for extracting like specific facts or figures from long documents where we just want to extract directly answers and get it going. So let's say if I have a huge context where I am just mentioning that Amazon rainforest is also known as Amazonia, and I'll talk more about the rainforest. And if I'll ask a question to that model, which is like, what's the other name for Amazon rainforest, then it will give me the answer based on the context I have provided it, and it will tell me that Amazonia is the output for my question asked. Then we talk about classifying text. So here we have language identification, we have text classification, and we have zero short text classification. So basically what language identification does, it detect the language of the input text we have provided. So let's say I have written bonjour comment uh, Java. It will tell you that which language it is written to, and it's written in a French, so it will predict uh, the output as a French language. After that, if we have a text classification, so it assign a label to a topic or a sentiment of the text. So for example, if my example input is the movie is absolutely fantastic, this is a positive sentiment that uh, this statement is conveying to us. So as a tag, it will mention that sentiment is positive. And third last, we have zero short text classification. So here we have some text which are classified based on custom categories that we provided at the inference time. So let's say if I give an input of the S&P dropped by significantly today, and I'll give you some custom labels to it, like it's a sport news or a business news or a entertainment news. So my model will predict that it's a business news, and that's what the response I'll get out of from it. After that, I have third one, which is search and compare text. So in that, it will turn each and every sentence into a vector, which is a numerical fingerprint capturing the meaning used for our semantic. So basically what it does, it converts your text into numerical vectors. Like I have a string or a text input, the quick brown fox jump over the lazy dog. It will convert this whole input text to a dense vector, where it will assign vector embeddings for the specific text, which is helpful for the searching purpose. After that, we have text similarity, where it compares the input text to a query and rank them based on the similarity. So let's say I have a question or input or a query where I am mentioning how many people live in Berlin, and a few documents have a document has this value message for Berlin has population of 3.3 million, which is be the closely ranked or close to what my question is. Whether if my another document has New York has message as New York has great museum, it will be relevant. The relevancy score for this message would be low. As you can see, it's minus 11.5. So that was all about NLP operations that we have in Elastic. Now I'll talk about the challenges and the challenges we are trying to solve. So over 80% of business data is unstructured, and support tickets, all the medical notes or any sort of logs we have are full of valuable information, but you cannot search on it, you cannot aggregate it or visualize it easily. So this lead to a decision delaying problem, poor automation on to the development side, or missing insights for the stakeholders or the business leaders. So that's where dealing with this unstructured data is a blind spot, and NLP with the Elasticsearch help us as a flashlight. And so what solution we have for it, we will use NLP to extract structure from our text, and any using NER tags we are finding important entities out of it. We'll store those enriched documents into the Elasticsearch, and then we'll go a step further. We'll use these sentence embedding in the represent to represent the meaning of our text. We have built a hybrid search methodology where we'll combine this keyword searching with the semantic similarity in a single query. And it's powerful. It's does not based on any specific industry, and it's very scalable, as you all aware of that Elastic is highly scalable in terms of horizontal or vertical scaling. Then let me walk you through over the implementation blueprint we have that worked in practice as well. So we'll start with some unstructured text, like let's say we have customer reviews. Then probably we'll ingest that customer reviews using ingest pipelines with the inference processor in it, which applies our transformation model on it. And these transformation model extract the entities and give you the entitles and do the classification on it, so that you will have more fields in it which are referenced as entities or ML references, which can help you doing your searching in a better way. You can also optionally set up some compute vectors embeddings on the semantic search. But if you don't want to do that, we can ingest it or enrich that document into the Elasticsearch. After using Kibana or other vector APIs, you can search on it, you can visualize it, and have things at a single place where you can make sense of it using the unstructured data, and you can structure it in a way where you are getting a lot of insights. So all of this runs in near real time, and it can scale for the billions of document. Now I would like to give some insights on different industries where we have seen this NLP NER works, and how it help in different industries to do their different job. If we talk about any retail industry, then we can extract some product names, issue types, and even this sorry even the sentiments from the reviews or tickets we have. It will help them predicting the product, or it will generate some tags which will help them giving the results for product and support improvements. If we talk about healthcare industry, then we can easily extract symptoms, conditions, medication from the doctor notes we have, out of which we can get some more insights about the electronic health records for the patients, their symptoms, the diagnostics they are going through. We can implement this in finance, legal, logistics, or if we talk about cybersecurity, we can use NER to extract logs from the IP, CVs, or attacks we have, different type of threat acts we have. So that's where it helps a lot in detecting insights from the unstructured data we have. We can also see using NLP, NER in media, news, education, and different industries where it can help us getting more insights. Now, I would like to talk a bit about the actual real world impact of this, and where we have using these NLP, NER with Elasticsearch, you can extract insights from the data which was not previously shown to you, or which was really unstructured at the beginning. You are making sense out of it and utilizing it in a way where you have proper insights now. As Elasticsearch is very fast, and the ingestion, as soon as your data is ingested to the Elasticsearch, it's ready to search. So the speed for real-time data ingestion and enrichment is as equivalent for data searching. If we talk about the flexibility, then it gives you a flexibility of choosing your own models to train your data, or to work on your NLP data in a way where you can modify it based on your use case. Also, you can use built-in models that Elastic provide within itself. For the scalability purpose, you can ingest like petabytes of data and search on it. It's very easy and ready to go. At last, for the precision or findability, we have hybrid search in place, where we can use our hybrid search to easily find or work on our data. So in short, you can go from a noisy data to a knowledgeable data. And some final thoughts I have on this would be Elastic is not just for storing your data, it's also helping you understand those data, and you can make insights out of it. Using NLP, NER, it allow you to treat your unstructured data to a structured gold. And whether you are utilizing or analyzing patient notes, food recall data, the blueprint is quite similar for all different cases. With that foundation in place, now I would like to pass on to my co-speaker, who would walk you through over how these NLP and NER techniques are being used for production to track food recall events and all. Thank you. Uh, I would let Mihalis share his screen and talk about food recall industry.
Amazing, Bhavesh. Thank you very much for your part of the presentation. Let me tell you, I was keeping notes while you were speaking. Some of the insights that you shared could be directly applicable to what we do, so thanks for that. And hello again to everyone. I am Carlis, as mentioned, and we're here to talk about our use case concerning the techniques and frameworks around NLP and NER over unstructured data in order to unlock hidden insights. Since I realized that we never shared our wow moment with Elasticsearch, it is actually what we plan on talking about throughout this presentation. So for us, Elasticsearch started as a storage engine somewhere in our stack. We will talk about this in a little while, but ended up being applied pretty much throughout our ETL workflows. It ended up being a production storage engine for us. So the wow moment I would like to share is the vast capabilities of Elasticsearch have definitely helped us evolve our product. And I mentioned the word us, who we are. We are here representing Agrono, the data and analytics company, using AI in order to predict food safety risks. And now, this is the initial tagline of our company. If we were to actually pass this piece of text, this sentence, over a IDF vectorizer, what it would highlight as the important keywords in this part, or significant terms, as Elasticsearch is calling them, it would be the following words or two words. First of all, we are in the industry of food safety. We will touch on that in a little while, but this is the industry that we're working in. And what we do is that we provide analytics and we train our predictive models on this industry in order to provide insights to companies such as Whole Foods, as the example of Babas mentioned in his presentation, over this kind of data. And now, as I'm sure the audience is very much familiar with, in order to do any kind of analytics, let alone train your own AI models, for forecasting models in our case, you need data. Data is indeed a core part of our business, and this is what we plan on talking about for the rest of this presentation. Let's take it, however, one step at a time. As we said, we are in the sector, in the industry of food safety. And now, what is food safety? As I'm sure everyone in the audience knows, everyone is consuming food. However, not all food is fit for human consumption. And by not fit for human or animal consumption, we're talking about product brands that may contain some kind of bacteria or pesticide residues, or even foreign bodies, pieces of plastic, glass. This kind of products, these products are not fit for human or animal consumption and should be recalled, taken down from supermarket shelves. This is the core of food safety. This is what the departments of food safety and quality in the food companies are dealing with. And this is the kind of data that we collect and process. And this is the job of actually governmental bodies spread around the world. You see here on the slide an indicative list of our food safety authorities, which basically is, I think I'm getting some background noise on my
Yeah, sorry for
headset.
that. I was able to mute the person. Thank you.
Yeah, no worries. So, as we're saying, these are the food safety authorities are what we call our data sources. These are governmental bodies that are dealing with this kind of checks. They are going over to supermarkets, taking down products, doing the respective food safety checks, and if there is a product that's not fit for human or animal consumption, they should let the world know and consumers so that this product is not consumed. Again, you see here an indicative list. As you may already be familiar with, these kind of food safety authorities are spread around the world. Pretty much every country around the world has one, and actually in some cases more than one, such as the case of the United States. And these are the data sources, the websites we pull our data from. To dive into the numbers a bit, you see here on the slide that, and these are actual numbers, by the way, pulled from our product, from a data product yesterday. So far, within 2025, we have collected, we have processed a bit more than 13,000 product recalls. These are product brands that were found not fit for human or animal consumption, that were already on supermarket shelves or trying to get into the borders of different countries. And a small note, if we compare this number to what happened in 2024, throughout 2024, we experienced close to 50,000 such product recalls. And these are the kind of data that we collect and process and are using Elasticsearch in order to enhance. In total, again, some background information. So far, in our data platform or tech stack that we plan on talking about for the rest of this presentation, we have collected a bit above 1 million data records of such product recalls. However, is these product recalls, these incidents, as we call them, all the data needed in order to fully cover the food safety sector? Quick answer is no. Longer answer is that we need other data in order to cover this sector holistically. And the longest possible answer is that you see here an indicative list of other data types that we collect and process to fully cover this sector. You see here on the slide, for instance, laboratory testing results. These are the results of monitoring programs from laboratories around the world. The volume we will touch on that is quite big, but also production data or trade data, price data is also important to fully cover and identify cases for the food safety sector. As Bhavesh also mentioned in his presentation, news items or even social media listening may prove of interest to what we do. And of course, regulatory data, inspection data, these are other kinds of data that we can use in order to fully cover the sector that we're dealing with. To again give some numbers into the picture, now you see here in the parentheses for each of these indicative data types that we have been collecting, the respective number of data records we have collected throughout the years. So for instance, laboratory testing results are a bit above 400 million. That, if you recall the slide that mentioned the food incidents, it's almost 400 times higher. The data volume is 400 times higher than the actual incidents. So you can think of them as potential early indicators in order to identify such cases, inform the food companies so that they can take proactively actions in order for the unfit food product never to reach supermarket shelves. Apart from that, other interesting cases are, of course, weather data or inspection data, price data, trade data, that you see, and you also see the respective volume in each parenthesis. Now, let's switch our attention to our tech stack or our data platform, as we mentioned, which is the technology stack that we use in order to incorporate, collect, process, and make available these close to 1.5 billion data records we have collected throughout the years. In the slide here, you see an actual representation of our technology stack. As you can imagine, using these components in different colors, we are following the microservice architecture. So our whole stack is split across different components, all of them communicating between one another using API endpoints. By the way, the actual technologies that we use are in this slide using the respective logos. But for now, let's focus on the following components. First, on the left, you see the crawling layer. This is the initial layer, the layer responsible for constantly scanning the web pages that we are keeping track of. By the way, keep in mind, we're tracking roughly 900 such web pages. Then the automatic ETL workflow is triggered through the transformer and enriched components. Each data record ends up in the curation layer that we will touch in a little while, where our food scientists in-house are reviewing the data and validating them before making them available. We are moving to the right side of the slide through our data API, stored, heavily relied on our production storage engine, Elasticsearch in this case. One final note before we move on is that, as you can see, throughout our stack, there are various small clusters of Elasticsearch used for different operations. Now, why do we do that, however? To go over a specific example, we have identified one here. Focus on the image on the screenshot on the left for now. This is an actual announcement by FDA, the food safety authority, one of the food safety authorities within the US, where there was a specific recall for hamburger due to the presence of some foreign bodies, some foreign material, specifically plastic fragments. This is an example of what we collect on the left, and on the right you see a screenshot from our software as a service product, Foodakai is the name, where we present to the end user the analyzed output based on the automatic process that we have, as well as the human validation step. So as you can see here, there are different data properties that we'll talk in a little while, but in a nutshell, we give the ability to our end users to identify what was the company behind the recall, product, date, and so on. To fully cover this, because this is what we plan on talking about and deep diving into Elasticsearch for the rest of this presentation, which are the important properties in a food recall. You see here 6 of the most important ones. First up, we have the ingredient. What was the ingredient that was recalled? What triggered the recall? Let's assume there was a case for salmonella in chicken. In this case, the ingredient would be chicken. Then we have the hazard, which is the reason behind the recall. In the example we're talking about, it would be salmonella. In the one that we've shown in the screenshots, it was the presence of a plastic fragment. Then we have what we call supplier, that you can think of it as the food company or food companies involved in this specific food recall or potential board rejection. Then we have the brand. What was the specific product brand that was recalled, ideally with a lot code, the best by date, so that we can also alert potentially the end consumers to check their own house whether they have this specific brand. Then we have the date. When did the actual recall take place? And finally, the country or countries of origin. These are the countries where the recalled ingredient was manufactured, was produced. So using this kind of properties, which by the way is available to all of our data records, our end users can perform data analytics, and we can also use this kind of data to train our forecasting models in order to predict what will take place over the next year. And as you can understand, since we're using this data in order to perform either data analytics or AI, data quality is a very important step for us. How do we ensure the data quality in our records? We're using a dedicated layer for that. We touched that a bit in the slide where we're showing our texture, but focus for now on what we call the curation layer. This is the layer responsible for the actual data quality that's ensured by the food scientists we have internally in our team. These are food scientists that are logging into our curation layer. By the way, we are using a CMS, specifically Drupal for that. They are logging into this instance in order to review and validate any kind of data that we collect and process before making them available to our end users in using the data API that we have in this image. As I'm sure you can understand, this is a time-consuming activity. Any human effort, of course, is time-consuming. So what we plan on talking about for the rest of this presentation, and in the meantime, I'm stop sharing my screen so I can give the floor to Yorgos, is how can we use technology and specifically the subsets of a specific framework of Elasticsearch in order to enhance the work done by our human experts. George, the floor is yours.
Thank you, Michalis. So, as Michalis mentioned, we talked about a little bit how the curation layer works. As he mentioned, it is a highly time-consuming task. That's why we also utilize automated enrichment process in our data platform in order to derive the useful information from every recall. So in this photo, where it is our data platform actually, on the bottom right part of it, we can see the technologies that we use in order to tackle this issue. First of all, you can see, of course, the Elasticsearch technology. You can see Keras, sklearn, Python, and in order to communicate these modules with each other, we use some wrapper APIs like Flask or Spring Boot. So, as it was also mentioned before, these are the important properties that every food recall should include. Let's see here, which is the goal regarding the ingredient property. So, sorry for that. So, on the left, you can see the FDA announcement of the food recall. You can see here the product hamburger buns in an unstructured form. The goal that we have is to map this specific term with the corresponding term in our hazard vocabulary, in our sorry for that. Okay. So, as I mentioned before, the hamburger buns are the products in an unstructured form, and we need in the right part to map it with the corresponding product vocabularies. Of course, we need to enrich our data continuously from data from the web, in this case with open data from the Wikipedia. Another very important property that we have is the hazards property. Hazard is, in simple words, the reason why a food recall occurs. For that reason, in this case, we also have that the reason of the food recall is the foreign material that was found in the hamburger buns. The goal here is quite the same. We want to match it with the hazard vocabularies, with a corresponding matching term on our vocabularies. So the big question is, how do we annotate all this information? How can we achieve all this kind of mapping in our daily routine? The answer and core of our architecture is, of course, Elasticsearch. Elasticsearch provides some useful NLP tools for this task. On the left side of this slide, you can see the examples of the analyzers that we employ. These are crucial components that process the raw text. For example, we use the lowercase filters and some stop words filters in order to remove common non-informative words like the word the or the word n. On the right side, you can see how these analyzers are integrated into our Elasticsearch schema, defining how the various fields are indexed and searched, enabling efficient annotation. But are all our problems solved? Of course not. Another problem that we face day to day is the language barrier. As Michalis mentioned before, food safety is a global concern, and naturally, as a result of it, food safety authorities worldwide announce their recalls in their native languages. In this example here, you can see that Belgium has its food recalls in French or Austria in German. That's why because we need to process all these recalls day to day, we cannot be limited to a single language. Because of that issue, we need to extend our schema, not only with synonyms. For example, here, we needed to have some synonyms for the word chicken, in this case, raw chicken or rotisserie chicken. In addition, though, as we can see on the right part of the slide, we need to extend our schema with multilingual terms of the word chicken. So let's get back to the important properties of every food recall. The suppliers is also an important property that is connected to a recall. It is actually the company that is in a way responsible for this specific food recall. On the left side here, we can see that the company Conagra Brands is in a way connected to this specific food recall. So to identify the suppliers within unstructured text, we leverage name entity recognition techniques. This allows us to automatically detect company names and also organizational entities in general. But we don't stop there. Once we have identified them, we go a step further in order to understand the relationships between the suppliers. The right part of the slide, as you can see, shows a graph depicting these relationships. But what a relationship between two suppliers can be. A usual case that we face is that supplier A supplies supplier B with a specific ingredient. Another case also is the company structure, as we can see here. Here, NatureWorks and Cargill Meat Solutions are subsidiary companies of Cargill. On the right part, you can see how all this information that we have on the left is in an aggregated form in order for the companies to have a better view of them. So let's talk a little bit now about the stats. Until today, we have information for more than 921,000 companies and around 18,000 terms in our vocabularies. These are the hazards and the ingredients vocabularies that we mentioned before. But the question is, okay, we have all this data and all this information now in a structured form. How can all this information be used? The final goal of all this architecture that we described is to help the work of our food scientists, which are responsible for delivering high quality data. But the numbers, as you saw, are huge. How can a human remember all these terms? In order to achieve this, we have developed a socialized mapping tool. This tool is the interface through which our food scientists interact with the enriched data. It leverages the power of Elasticsearch, allowing them to effectively map and annotate all the information that we gather from the web regarding food safety. We want to align it so with the data platform vocabularies and in general our internal knowledge bases. Time for some numbers again. So our data platform until today has successfully collected and processed over 1.4 billion data records. These datasets are the core of our insights that we offer, enabling us to identify trends, predict potential issues, and provide intelligence in general around the food safety domain. We're happy to share with you that for our work, we also got an award from the Elasticsearch in 2019, which we are very happy about it. And I think that's all for us. Now we can open the floor now for the QA session.
Thank you so much, Mihalis, George, and Bhavesh. It was a fantastic session, and I'm sure we have gained some insightful ideas. And congratulations on the award, Mihalis and George. And yes, now we will open the floor to Q&A. So let's check our chat box. So Dhruvi has asked us, how do you handle entity disambiguation in NER, especially when entities have overlapping names or meanings?
So probably I can start and then Mihalis, George, feel free to add your points in it. So that's a really good question. And entity disambiguation is one of the biggest challenge we have in NER, especially when the entities share the same name or the context. So it's all about finding the right meaning when entities share the same name. Let's, for example, we have an apple as a fruit as well as we have Apple as a company. So in Elastic, we can typically handle this by using context awareness models like BERT, where we understand the meaning of the nearby words. We train some domain specific models onto the industry data we are using. Then we can probably go with the entity types to narrow down our options. Like if we want to set up some tags like organization or based on the location, or we can set up elastic filtering using the metadata for the tags of those data we are using. So maybe Mihalis, if you want to add anything on that.
No, I definitely agree with what you described, Alves. I can share some insights on how we are doing this internally, because as the example of George also mentioned, this is the case for us for company names. So let's take a specific example. Cargill may be mentioned as Cargill, which is a company name, may be mentioned as Cargill Inc., Cargill Inc. full stop. In all of these cases, the Cargill or Cargill Inc. part is an organization and is a company. So the way that we handle this internally is that we actually split this process into two steps. The first one is running the piece of text through the NER workflow to identify the pieces of text, the words that are assigned to an organization. And then we're using our data schema because we're aggregating this information. So we have all these entries for Cargill, but we have one, let's say, master entry of Cargill, under which we have the alternative names of Cargill, such as Cargill Link, and so on. So basically, we split this under two steps.
Amazing. Okay, so Zineb has asked, how long does it take to train on your data? Also, do you train from scratch or is it fine-tuning using an already existing Elasticsearch NLP model?
So fine-tuning a pre-trained model like BERT or any model we have in Elastic might take just few hours to a day. But if you want to train something from scratch, which is rarely needed in Elastic because it already provides you a lot of inbuilt models, so it's not required. But if it's required, then it's probably costly and slow. It can take from like days to weeks to train your model. But as I said, Elasticsearch recommend their fine-tuning doing on the specific domain that you are using. So using all the pre-built existing models and then deploy them onto the Elastic and fine-tune based on that. Hope that answers your question.
Okay. Um,
Then I see one from Ayush about
yeah.
NER pipelines look like distinguish between the word Python and the language. So uh, as I said and I mentioned that NER pipelines relies on the contextual model, language model that we are using. So overlapping names like Python, which Elastic supports, are transformed using the BERT model that we are using. So at the time of ingesting the data using the inference processor, we can set the context of the inputs we have, and based on that, we can identify which context of the words we are using it in.
Okay. Naman has asked, what challenges have you faced when deploying NLP plus NER solutions in real time or near real time environments?
So, if I talk about it, then probably there are few uh, challenges that I have personally faced, and Mahal as George can tell them about their experiences. One is the latency. So, when we work with the large models, they can be slow during the time of ingestion. While we are ingesting our data through the ingest pipelines, if we talk about model size, then large model size need more memory or CPU, which can impact your performance. Apart from this, handling error for bad or noisy input can break our inferences processor during the processing time, which we need for validating our input. Apart from this, working a bit on throughput and accuracy trade-off to make our models bit more uh, fast and less precise can affect the performance a bit.
And if I may build up on what just Pavel described, for our use case, which I guess it's a bit of a unique one, time is actually not a requirement. So we are more on the near real-time part. So time is not a requirement. What proved to be more challenging for us and how to implement the respective piece of technology accordingly is that explainability was more important because keep in mind that each of our data records end up being validated by a human expert. these human experts need to know that, okay, the NLP or NER model suggested term X, Y, Z, but why did it suggest that? So they need this piece of information in order to validate the output.
Thank you so much.
Maybe you can take this as well, which is like what are the uh, best practices for integrating domain-specific ontologies for NER models?
Excellent question. Now, I'm not sure if we're talking about best practices. At least for us, it's what we do. It has proven to be a best practice, but I guess it depends on the use case. So if what we did is that we started, of course, when we started the product, there was no vocabulary, there was no taxonomy, and we needed to create one. So we relied on publicly available ontologies to initially create a draft of our vocabulary. This is a very important initial step because it allowed us to have the power of hierarchies based on the work already done on ontologies and also directly link what we had as initial input with other vocabularies out there. This is the first step. But the second one that we did throughout the years is that we had the initial draft, but we are constantly expanding on that, constantly adding new vocabularies, new ontologies, adjusting the hierarchy to make sure that it aligns with our use case. So removing terms, grouping terms together. So our suggestion would be start from what's out there, but we would suggest playing around with it up until it aligns fully with what you want to do.
Amazing. Ayush has again asked, can pre-processing steps like lemmatization and removing stop words lead to better NER identification?
So that's not always the case when we talk about NER. Lemmatization or removing the stop words can sometimes hurt NER models as well because these models fully rely on the context we are feeding in. So pre-trained NER models worked with the raw untempered text that we are using, and if we are using pre-processing models, then we use it only to train model for a similar characteristic with the unstructured data without cleaning up from our side. We'll let the model train itself based on the original text or original context we have. And then we can pre-process it later based on doing separation for searching or classification on it. Also, I see a good question from Dhruvi, which is how we manage privacy concerns uh, and compliances when dealing with sensitive unstructured data. So that's a really good question. When we deal with government agencies or healthcare data, that's where we have to make sure that we are following the compliances and taking care of all the sensitive data. And for that, we make sure that we do the field level security of all the data we have, so that we don't mess with the the security of the data. Apart from this, we make sure that we all the PII PHIs during the ingestion time are using NER models that we have. We enable audit monitoring and audit logging for traceability based on the HIPAA compliance, and for the encryption of data, we make sure that our data is encrypted and stored into the Elastic. Mihalis, feel free to add any point if I'm missing.
No, these were amazing point, Bhavas. Small note from us, and again, it is dependent on our use case. What we do internally, if you recall, our tech stack is dependent on the microservice architecture, and this is how we build that. So the communication across components is done through API endpoints, which of course have their own API keys and authentication mechanism embedded on that. So what we do in order to ensure that no privacy, no data leaks, no component has access to what shouldn't, the kind of data that they shouldn't have, is that we enforce this kind of security mechanisms on an endpoint level based on the authentication mechanism applied by each of our API projects. So as to make sure that the whole workflow runs with the data and the insights that they can actually access.
George, do you have anything to add?
As Michalis mentioned, through the APIs, we manage to have the security the security coverage that we want.
Well, thank you so much. This was a fantastic session. Mihalis, George, and Bhavesh, thank you so much for sharing your insights. And thank you to everyone who joined us. We hope you're walking away with ideas that you want to explore further. In our chat box, we have put links of Mihalis, George, and Bhavesh. We have mailed, not mailed, sorry. We have put their LinkedIn links and Agrono's website. I'd also like to tell you before we go that the session was recorded and it will be available soon on our website. If you are interested in collaborating with us for our future webinars, please feel free to connect with us. I will drop the links in the chat box. And if you want to know anything about Elasticsearch, please feel free again to contact us via our contact page, LinkedIn, or email. So I will just drop it in the chat box below. Thank you so much, everyone, for joining us, and have a great day.